Hello guys, welcome back to my channel. It's me again, Clang, and welcome to another episode of Miss Billion's Classroom. Today, we are going to talk about concentrations as solutions. But before we proceed, don't forget to hit like, subscribe, and ring the notification bell. Okay, let's start. So we are going to start with the definition. Solution. Solution is a mixture of two or more substances that is identical throughout. Solution is an example of homogeneous mixture. Okay, homo means same. All right. So in a solution, like what we have said, it's a mixture of two or more substances, regardless of how many substances present in this mixture. As long as they are identical throughout, or we are only seeing one phase, they are considered as homogeneous. We thought that solution is only liquid in form, but in fact, we also have solid solution and gas solution. So, example of gas solution is air. Air is a mixture of different gases: oxygen, argon, hydrogen gas. They are mixture, but we only see one phase, or actually we can't see the air, but they are identical throughout. We cannot identify what is oxygen, what is hydrogen, what is argon. We all know that is air, okay? Because they are identical throughout. How about solid solution? An example of solid solution is jewelry. So say for example, you have a ring, okay? You know that you have a gold ring, but did you know that it's not pure gold? It's a mixture, all right? And that is an example of solution. A solution can be physically separated. Let's say, for example, the salt water. Salt water is considered as a solution. Okay, the question is salt water can be separated physically? The answer is yes. Okay, so how are we going to physically separate the salt water? By means of distillation. Very good. So now, another characteristic of solution is composed of solutes and solvent. This is very important. Solute is the one that is being dissolved, okay? While solvent, this is the one that is used to dissolve. So say for example, in an iced tea, we know that iced tea is a solution, okay? How do we prepare iced tea? We have the iced tea mix and the water, okay? So iced tea mix is considered as the solute, while the water, as the universal solvent, is considered to be the solvent. When we mix them together, they are considered as a solution. Remember, solvent is the largest part of the solution, and the solute is the smallest part of the solution. Let's think this way. Let us use the word solvent and solute. As you can see in your screen, solvent has more letters than the word solute. So, always remember, solvent is the largest of the solution and solute is the smallest. Alright, so let's talk about the next word, which is concentration. So concentration is the amount of solute dissolved in a solvent at a given temperature. Your concentration could be diluted or concentrated. When we say diluted, it has a low concentration of solute dissolved, while concentrated, it has a high concentration of solute dissolved. Example, you're familiar with the hydrogen peroxide that you use for your wounds, right? So that hydrogen peroxide that we are using for our wounds actually have only 3% of the hydrogen peroxide solute, and the rest is solvent, which is water. But the concentrated hydrogen peroxide in real life can be or can cause you burn. Let's talk about the different types of saturation. Your solution can be unsaturated, saturated, or supersaturated. what is the difference of these three? So let's say we are going to mix or to prepare a solution. We are going to consider a solution as unsaturated if the solute is totally dissolved in the solvent. If there are little crystals or solid on the bottom part, that is considered saturated. But if the solute didn't dissolve in that solvent in a normal temperature, that is considered supersaturated. Okay, for that solute to be dissolved, we need to add up some temperature. Okay, now let's move on with the units of concentration. We're going to discuss the first two first, since they have the same formula, the percent by volume and percent by mass. The only difference is the unit of measurement. For the percent volume, we're going to use, of course, the volume of the solute and the solvent. And for the percent by mass, we're going to use the mass of solute and the solvent. So as you can see in the formula, we're just going to divide the volume of solute, volume or mass of solute, and the volume or mass of the solution times 100. That is very easy. Again, remember, in solution, it always an addition of solvent and solute. Now let's have the first example. For our first example, it says that what is the percent by volume concentration of a solution in which 75.0 ml of ethanol is diluted to a volume of 250.0 ml. So the first thing that we're going to do is to identify what is our unknown. Okay, our unknown, I will use N for our unknown. So the question is, what is the percent by volume? Percent by volume. So therefore, we're going to use, or the unknown will be percent by volume. Forgive my handwriting. And now let's find the given. Okay, given. Oops. My Apple Pen is not working now, so I'm just using my mouse. Sorry about that. So for the given, what is our given? First, we need to find the solute and the solvent. We should know what is the difference between solute and solvent. Remember, solute is the one that is being dissolved, and solvent is the one that is used to dissolve. So since we're looking for volume, we need to find the volume of solute. So V solute, I will just like VSOL. Okay, is equals to. So for here, we have 75.0 ml of ethanol is diluted to a volume of 250.0 ml. So therefore, the 75.0 ml of ethanol is our solute. So we will write here 75.0 ml. Don't forget the unit. That is very important for me. And next, for the volume of solvent, okay, solve. I will just write SOLV. All right. For our solvent, it is clearly the 250 ml. Okay. Now, let's go on with the solution. Okay, solution. SOLN. All right. So remember, our formula is volume of solute over volume of solvent times 100. So our solute is 75.0 ml and our solvent is 250 ml. So percent, oops. Okay, hold up. Okay, so percent by volume is equals to 75.0 ml over 250 ml times 100. Alright, so now in the calculator, 75.0 ml divided by 250.0 ml is 0.3 ml. Okay, times, of course, 100. So that is clearly 30%. So that is our final answer. So the percent per volume is 30%. Oops. So that's it. Okay, so let's move on with our second example. What volume of acetic acid is present in a volume containing 350 ml of solution which measures 5.0% of concentration? So for our unknown, okay, it is clearly said it's the volume of acetic acid and the solvent is given and the percent concentration is given. So the volume of solute. Okay, for our given, okay, the given is the volume of the solvent, which is 350 ml, and the percent by volume, which is 5.0%. Okay, for an easy computation, I will convert this first to decimal. So 5.0% is 0.5%. Remember, just move two decimal places to the left. Should I say 0.05% or 0.05 rather? Okay, and then now let's go on with the solution. Okay, we'll just plug in or substitute all the given we have with a solution. So 0.05, which is the percent by volume. All right. And then we have volume of solute over our volume of solvent, which is 350 ml. Okay. So now what are we going to do is to cross multiply. So this is automatic over 1. So 0.05 times 350 ml. We put parenthesis 350.0 ml. Okay, is equals to volume of solute. So 0.05 times 350 ml, that is 17.5 ml. Oops. So that is our volume of solute. There you are. Our first two example is percent by volume. Now let's have an example of percent by mass. Okay. Our example says find the percent by mass in which 41.0 grams of NaCl or sodium chloride is dissolved in 331 grams of water. All right, so our unknown is percent by mass. Okay. And then our given will be for the mass of solute, okay, is the 41.0 grams. And the mass of, solvent, all right, is 331 grams of water. Remember the formula for percent by mass is mass of solute over mass of solvent times 100. So we're just going to plug that in or substitute. So percent by weight or percent by mass is equals to 41.0 grams over 331. Forgive my handwriting again, so I'm using only my mouse. So that is 41.0 grams divided by 331 times 100. That is 12.39%. There you have it. That is very simple, right? Now let's have the third one, which is the percent by mass and volume. Okay, so the percent by mass and volume is equals to the mass of solute times 100 of a solution. So in here is little complicated because we need a conversion factor of the mass and the volume since they are of different quantities. Now let's have this example. How many ml of 4.20% mass by volume will contain 3.15 grams of potassium chloride? Now let's have our unknown. Our unknown is how many ml. So basically, ml is a unit for volume. So our N or unknown is volume of the solvent. All right. And for our given, okay, so we have 3.15 gram of potassium chloride. So that is the mass. Okay, 3.15 grams. All right, and the percent by mass and volume, which is 4.20%. Okay, so what is the next thing that we're going to do? So we are going to get the conversion factor. Like what I've told you, we need conversion factor here since they are of different quantities. What is the conversion factor that we're going to use? All right, so since this one, our mass or percent mass per volume, okay, we're going to use that. So the conversion will be 4.20 grams of KCl. I'm not going to write the KCl anymore. Over 100 ml of a solution. Okay. Or the vice versa. 100 ml of solution over 4.20 grams. Why do we need to put two conversion factor? So you will see later what or which conversion factor you are going to use in the solution. Okay, so for our solution, let's plug in or substitute the given. Okay, so we have 3.15 grams of the solute. So that will be, okay, again, we're looking for the volume of the solvent, right? Oops. Okay. So in here, we're going to write 3.15, which is the mass of the solute, times, okay, I'm going to use this one. I'm going to explain why. I'm going to write it first. Okay. Why did I use this conversion factor? Because our goal is to get the volume, which is the unit is ml. So we don't want the grams. So we need to cancel that. So enable for us to cancel is the unit should be one in numerator and the other one is denominator. So this is automatically over 1. So cancel grams. All right. And then our formula will now be, or solution will now be 3.15 times 100 divided by 4.20 grams. And that is 75 ml. So that is our volume of solvent. That's it. There you have it, guys. I hope you learned something today. I hope it is clear to you what is concentrations of solutions. I'm sorry about the handwriting. I promise next time I will try my best. Um, so yeah, if you like and learn from this video, please don't forget to like the video, hit subscribe, and ring the notification bell. Thank you. Have a good day.